So in chapter 3, we talked about supply and demand, and we had the basic downward sloping demand curve and upward sloping supply curve. We drew them pretty simply like a 45-degree angle, just because all we really cared about was which direction the curves were facing. But now we're going to look at just what the slope of those curves can be. Depending on the market, they can be different slopes. And a different slope is a different sensitivity to price, or as we call it in economics, elasticity. So we're going to begin this chapter by looking at the economic concept of elasticity and understanding how firms and consumers are sensitive to changes in different things. The first thing and the main thing we're going to focus on is the price elasticity of demand. So how much consumers' demand is going to change based on a change in price, how sensitive they are to a change in price. We'll then look at cross elasticity of demand, income elasticity, and other elasticity of demand measures. So we'll see how consumer demand is, how sensitive it is to change in several different things. But again, like I said, the price elasticity of demand is going to be the main thing we focus on. We'll then look at the elasticity of supply, so see how firms are sensitive to changes in price. Let's begin with the first type of elasticity we're going to talk about this chapter, which is the price elasticity of demand. Price elasticity of demand is basically how responsive consumers' demand is going to be to a change in the price of a good or service. Mathematically, we can say it's the percentage change in the quantity demanded divided by the percentage change in price. And remember, when we're working with mathematical equations, the Greek letter delta, or the triangle or pyramid, that means a change in. So literally a percent change in the quantity divided by a percent change in the price equals the price elasticity of demand. Now, this is something that's very important for businesses because businesses actually have control over their actions related to the price elasticity of demand. So basically, if you're a firm and you want to cut prices in order to get more consumers, you need to be aware of the price elasticity of demand. If consumers are extremely responsive to a change in price, you'll get a lot more consumers by lowering the price just a little bit. Then your revenue is likely to increase. However, if consumers aren't very sensitive to a change in price, if you lower your prices, you won't get that much additional revenue from new consumers purchasing your product. So then you end up not making that much money. Your revenue actually goes down because of the lost revenue from the lower prices on all the units you would have sold anyway. So it's very important to understand the price elasticity of demand as a concept and to be able to somehow estimate it roughly for the product that you're working with and trying to reach a decision on. So the first way to measure price elasticity of demand is using what's called arc elasticity. This is the most common method used in economics textbooks. Now this formula is a little bit more complex with the actual figures in here versus the simple one we saw in the previous slide. So EP is the arc price elasticity, E for elasticity, and the subscript P denoting that it's price elasticity versus one of the other types of elasticities we'll talk about later. So that equals the change in the quantity divided by the average quantity. So we have Q2, which is the new quantity demanded, minus Q1, which is the original quantity demanded. That's going to be the difference. And in order to make it the percent change in quantity, because remember that's what we wanted, we're going to divide that number by Q1 plus Q2, so the sum of the original quantity and the new quantity demanded, and then divide that by 2, so we're taking the average of it. So it's the change in the quantity demanded divided by the average quantity demanded. That's going to be our numerator. Our denominator is going to be P2 minus P1 divided by P1 plus P2 divided by 2. So P2 is the new price, P1 is the original price. So that gets us the difference in price. Then we're going to divide that by the average price. So P1 plus P2 divided by 2. So now why do we use the average quantity and the average price in this instead of just one of the original price? The reason we do that is because the arc price elasticity, this expanded equation, will give you the same answer whether you're moving from one price to another up or from one price to the other down. So for instance, if the change in price goes from $12 to $14, so if it increases, you will get one answer, and if you go from $14 down to the $12, you will get a different answer. So the magnitudes will be different. The textbook kind of walks you through there with the math, but the idea is which way you go, which way the price changes, will change your calculation for the price elasticity of demand unless you take the average of the quantity and the average of the price for your equation. So it's a little more math. Again, it's a little bit more annoying, there's more numbers to juggle around, but it will get you the actual accurate answer instead of the wrong answer. Now the arc price elasticity of demand covers the elasticity of demand over a range of values. So for instance, I gave the example of going from 12 to 14 or from 14 to 12, but whichever points you choose, or if the price change is different, you'll get different values for the price elasticity of demand. Again, your textbook covers this more in depth. I don't want to waste your time going through all the math, but conceptually, basically when we're using this expanded formula, the points that you choose, so the price or the quantity that you choose and what that changes, whether it's when it's different, you end up with a different price elasticity of demand because the price elasticity of demand changes throughout the curve. So while the arc price elasticity, that method is useful sometimes, in other applications it's not going to be useful. So we're going to want to use a different formula, or slightly different formula, called the point elasticity of demand. The point elasticity measures the elasticity at one given point of a demand or a supply curve. So that's instead of estimating this over a range of prices like we did for the arc elasticity of demand. So the point elasticity is going to try to estimate the price elasticity of demand at one specific point rather than over a range of values like the arc elasticity of demand. So the equation is going to be a little bit different. Now elasticity here is represented by the Greek letter epsilon, and there's a subscript p again to denote that this is the price elasticity. So epsilon p is going to be equal to the change in the quantity divided by the change in price times the price divided by the quantity at that point that we're interested in calculating the elasticity for. So here's an example using table 4.1 from our book. Here's a hypothetical demand schedule. So the price at $18, the quantity demanded is 0. At the price of $17, the quantity demanded is 2. The price of $16, quantity demanded 4, so on and so forth, all the way down to when the price is $12, the quantity demanded equals 12. So if we wanted to calculate the point elasticity for the price elasticity of demand, what we're going to do is take the change in Q divided by the change in P. So that's basically going to be our slope, or it is going to be our slope. So it'll be -2. Then we multiply that by P1 divided by Q1. Let's say in this instance, we want to know what the point elasticity of demand is for a price of $12. So at the price of $12, the quantity demanded is also going to be $12. So we have our -2 times 12 divided by 12. 12 divided by 12 equals 1. So -2 times 1 equals -2. So our point elasticity of demand for a price of $12 for this hypothetical good is going to be -2. Now so far we've only used linear supply and demand curves in our example, and that's what these equations work for. If we're dealing with non-linear curves, so curves that have some kind of an exponential shape to it, some kind of a curve rather than a straight line, the calculation is more complicated. Because of that, we're going to need to rely on calculus, and we'll need to take derivatives. So in this instance, the elasticity of demand, when we're working with a non-linear demand curve, is going to be the derivative of Q with respect to P times P1 divided by Q1. So basically what the derivative can be thought of, for those of you that haven't had calculus, is the instantaneous version of slope. So it's a slope at that one specific point. What you're trying to do is calculate a line that is tangent, so it only touches at that one specific point. And things can get even worse when we're looking at nonlinear demand curves with a constant elasticity. So let's look at a simple demand curve in this situation. So Q equals A times the price to the negative B power. So negative B is going to be the elasticity coefficient here. This is going to be on a typical price and quantity, like supply and demand curve, like graph that we typically graph on. It's going to be a curved line. If we take the log of both the price and the quantity, we'll end up with a straight line. This, along with the nonlinear demand curve, is more complicated than we need to get into in this course right now. Later on in chapter 5, we're going to be dealing with these types of concepts a little bit more, so that we'll get a little bit more complicated. But we'll go more in depth, and I'll teach you exactly what you need to learn then, rather than wasting your time on things that are impractical now. But the idea is that while the first example was fairly simple, we get into more and more complicated situations as we have more accurate or different demand curves. Now, getting back to more practical things that we can actually use, economists categorize the levels of elasticity of demand. So if we say that a good is relatively elastic, or the demand for that good is relatively elastic, what we mean is that the elasticity is greater than 1. Now, of course, with elasticity of demand, all the numbers are going to be negative. So for this section, for price elasticity of demand, we're going to be taking the absolute value of those numbers. So the absolute value of -2, or the distance of -2 from 0 on a number line, is 2. So basically, you can think of us as just dropping the negative. So if the price elasticity of demand is greater than 1, then we call that relatively elastic. So by elastic, we mean that it is sensitive to a change in the price. Now, if demand is between 1 and 0, we call that relatively inelastic. So if it's less than 1, consumers are not very responsive to a change in price. So the price falls substantially, they're not going to buy a lot more. If the price increases substantially, they're not going to purchase a lot less. And we have the unit elasticity of demand. That's when the price elasticity of demand equals exactly 1. So there's a 1-for-1 change. A 1% change in the price leads to a 1% change in the quantity demanded in the opposite direction. So a 1% increase in price, or say a 10% increase in price, will lead to a 10% decrease in the quantity demanded. And then we have two special situations. They don't occur very frequently, but those are perfect elasticity and imperfect elasticity. So if the demand for a good is perfectly elastic, it is infinitely sensitive to price. So if you increase the price of a good or service at all, consumers are not going to purchase any of it. So it will immediately go to 0. And we'll see this comes into play in perfectly competitive markets. You can also have perfectly inelastic demand. And for that, no matter how high the seller sets the price, consumers are always going to demand the good. They are not responsive to a change in price at all. I don't know if there's a really good real-world example for when it's actually 0, but there's a lot of goods that can get very close to 0. These are things like pharmaceuticals that people need to survive, or illegal drugs and things that are physically, chemically addictive. That you cannot live without. So no matter how high the seller makes the price, the consumer is going to go out and buy it. So now that we've described what elasticity is and compare the relative levels of elasticity, we can talk about the factors that affect demand elasticity. So why is it that some goods have elastic demand, where consumers are sensitive to a change in price, and other goods have inelastic demand, where consumers are relatively unconcerned with price? Any price change isn't going to really affect their decision making. Now, it's important to remember that the elasticity of demand for a product changes at different prices. So where you are on the demand curve affects where the price elasticity of demand is. So it may seem to be 0. So the price elasticity of demand for salt is very, very low, possibly zero, around its current price. But if the price of salt increased to, 10, 100, $1,000 per pound, eventually you're going to start to see the price elasticity of demand increasing. Now, a very simple way to look at it is demand is inelastic for goods that are considered to be necessities and elastic for goods that are considered luxury products. So if you need something to survive, you're going to be willing to spend money on it even if the price increases. While this is a good, simple way of looking at it, that's not the best way because there are edge cases. One person defines as a necessity, another person may define as a luxury, things like that. So there's a few factors we need to think about. So the first is the ease of substitution. So if there are, a lot of other products that you could purchase that serve the same sort of goal, that meets the same sort of needs as the product in question, then consumer demand is going to tend to be more elastic because they have other options. They'll be more sensitive to a change in price. So if you think of the market for delivering packages, you have UPS, FedEx, the post office, you have DHS, a few other companies. So if you look at the market just for UPS, say, because there's other substitution, you can go to other companies and get the service from them, which is fairly similar. Consumers are going to be more responsive to a change in price. So if UPS changes their prices, they increase the price, to ship a package, the consumer can just go to the post office instead. They can go to one of their competitors that offer very similar, sort of service. Another factor affecting that is the proportion of the price of a good in your total expenditures. So if you're spending a small portion of your annual salary on a good or service, you're going to be less sensitive to a change in price. So salt is the best example of that. Consumer demand for salt is relatively inelastic, and the reason for that is you spend maybe $10 on salt a year at the most. It's a small portion of your annual paycheck, so a change in price isn't really going to bother you. Whereas if the price of new automobiles increases, because that's a large portion of your annual salary, consumers are going to be a lot more sensitive to a change in price for automobiles. Another factor affecting the elasticity of demand is the length of time period we're looking at. So if the price of gas increases in the short run, that may be considered a necessity for you because you have to drive to work, you still have to run the errands. You may be able to economize a little bit, so you only go out one day and you do all your errands rather than driving out, every single night just doing one. But in general, there's a decent amount of driving that you just can't get rid of in the short run. And it's not very easy to substitute. So if you're commuting to St. Francis, say from Altoona or from Johnstown, you have to make that drive every day. You don't have a choice. You don't have a bus you can take or something like that. So in the short run, consumers are going to be relatively inelastic for their demand of gasoline. But in the longer run, if we increase the time, consumers have more substitutes. They have a wider range of options. In the longer run, you can move closer to Loretto. You could buy an electric car or a hybrid, something that uses less gas or no gas. You can, maybe there's a public transit line from, say, Evansburg that takes you to Loretto. There's a special bus. Maybe you move to Evansburg and you can now take public transportation. In the short term, you don't have these options, but over the longer term, you do. So the price elasticity of demand is going to be relatively more elastic in the long run and inelastic in the short run. The final factor affecting the price elasticity of demand is the durability of a product. When you have something like a washing machine, what we call durable goods, consumers tend to have several different choices. So they can postpone their purchase, they can use someone else's, so they can go to a laundromat or maybe use their parents or one of their friends. So they can postpone their purchase in the future. So that extends the time period we're looking at. There's also the possibility of repair. They can repair their old washing machine. So instead of purchasing a new one, if the price is high, if there's a sudden increase in price, they can just choose to repair an old one rather than going out and buying a new one. And that's not something you see for, for some like cheaper goods that we'll focus on. And there's also a used product market often. So you can go on Craigslist, you can go on Facebook Marketplace, wherever, and you can purchase old used appliances. So in this case, old washing machines. So because there's a range of choices, you have more options for these durable products, consumers are going to be more sensitive to a change in price. Thus far, we've talked about the price elasticity of demand for final consumer goods. Now, the examples I gave are final consumer goods, but it wasn't something I specifically mentioned. But there's another concept of what's called derived demand. What we mean by derived demand is that these are components of a final product. So you're a firm, you're going to purchase certain commodities, raw materials. You're also going to purchase some what can also be called intermediate goods, so goods that are produced by other firms that are only going to be used in the production of other products. Sometimes they're going to be components in your product, sometimes they're going to be tools or capital, whatever used to actually produce that product. So the demand for these components that go into the production of final goods and services that are sold to consumers are called derived demand. The reason they call it derived demand is because the only reason demand for these products exist is because there's demand for their final product. So the demand for these goods are derived from the demand for the consumer good or service. So Alfred Marshall described 4 basic principles governing the elasticity of the derived demand curve. So these 4 principles are that derived demand curve will be more elastic, so less sensitive to price. The more essential the component is to the final good, the more inelastic the demand curve for the final product is. The smaller the fraction of the total cost going to the component, and the more inelastic the supply curve of the cooperating factors or the other intermediate goods are. So let's talk through an example so this makes more sense. So let's consider the demand for residential housing. That's going to be our final product. And the derived demand curve for one of the components of housing, the services of electricians. So the demand for electricians doesn't exist for its own sake, but it's due to the demand, that consumers have for housing. That's why we have electricity. So probably all of Marshall's principles are going to apply in this case, but we'll focus on 2 of the important ones. The first is just the essential nature of electricity, that it is an essential component in producing housing. You need electricity for a house. Very few people will be willing to purchase a house that does not have electricity. The second is the cost of electrical work is a relatively small percentage of the entire cost of a house. So let's think of an example where electricians are able to get a substantial wage increase. So while contractors may try to cut some corners here and there with electrical work, it still has to be done. So the employment of electricians is not going to decrease very much. So basically the elasticity of demand for electricians is low. If there's a wage increase for electricians, so the cost of electricians increase, home builders are still going to have to, hire them for the same amount of services or close to the same amount of services. Now let's think of how much the cost of electricians is compared to the overall cost of putting together housing. Let's say that the work of electricians is 10% of the total cost of construction. This is a way overestimate, but we'll use 10% to keep the math easy. If they are able to obtain a 10% wage increase, that's only a 1% increase in the total cost of production of the house. So it's going to be a relatively small component. So the smaller the fraction of the total cost going to this component, the more elastic demand is going to be. So because the amount of money going to the electricians versus the entire cost of production of a house is going to be small, again, demand for electricians is going to be inelastic. Like we talked about earlier, the price elasticity of demand is different in the short run than it is in the long run. So time is definitely a factor. So here, when we say short run, What we mean is an amount of time that doesn't permit the full adjustment by consumers to a price change. So they don't have their full range of options. So the example for gasoline, it's not a long enough time for them to be able to buy a new house or to switch to like a new expensive electric car. In the shortest of short runs, so say the morning you're going to work, if you see gas increases, no adjustment may be possible. So the demand curve over that range may be almost perfectly inelastic. So the morning you're going to work, you don't have a choice, you don't have other options, you just have to get in your car, buy gas, and go. But as the time period lengthens, consumers are going to find ways to adjust to that price change by using some sort of substitute. So maybe by buying a new car, maybe by carpooling with friends to work, and maybe by buying a house closer to work. So that you could just like walk there, or you could take a bus. So the figure on the right is comes from one of Milton Friedman's old textbooks that he wrote. So we see the demand curve with the light blue, the DL is the demand curve for the long term. And then we have DS5, DS4, DS3, DS2, DS1. All of these are short run demand curves. The short run demand curves have a steeper slope. So we can see graphically that they are relatively inelastic. So as the price changes from P1 to P2, looking at demand curve DS1, so in the short run there, moving from P1 to P2 is only going to move from point A to point B. So at point A, Q equals Q1. At point B, Q equals Q2. These are relatively close to each other. So consumers are not very elastic. They're not sensitive to a change in price. Again, that's because in the short run, there's fewer substitutes, so on and so forth. Now, for the demand curve for the long term, the DL, if we move from P1 to P2, so price increases there from point A to point C, where the demand curve crosses at the new price, what we see is the quantity demanded is going to decrease from Q1 to Q3. The difference is much larger, so consumers are much more responsive to a change in the price. The quantity demanded falls by much more than we saw in the short run. So it's just a graphical representation of what we just talked about. Okay, so price elasticity of demand, how much consumers are willing to change their purchase if the price changes. Okay, like that can be somewhat interesting maybe, but how does this actually apply to businesses? Like why would a business actually care? Well, if you're managing a business, you're trying to make decisions, what you do care about is things like your total revenue. And the price elasticity of demand does affect the total revenue that a firm is going to have. So if you think about a price change very simply, if you lower the price of your product and nothing else has happened, the quantity demanded does not change, what's going to happen to your revenue? Your revenue is going to fall. But if you're able to sell enough additional units from that lower price, you can make up that money you lose and actually make more money, end up with higher revenue. So whether a good is elastic or inelastic, whether consumers are more responsive to a change in price, will determine whether your revenue is going to increase or decrease based off a price change. So when a good is elastic or demand for a good is elastic and you increase the prices so consumers are responsive to a change in price, the total revenue is going to fall. Now, if you decrease the price of a good that the price elasticity of demand is relatively inelastic, you'll end up with a higher total revenue. So because consumers are sensitive to a change in price, if you lower the price of your product, you will increase the demand substantially. Consumers will purchase a lot more of your product. So it'll end up increasing the total revenue. On the other hand, if the price elasticity of demand for a good is relatively inelastic and you increase the prices, you're going to increase the total revenue. Again, the reason being that if consumers aren't very responsive to a change in price and you increase the price, you're not going to lose that many consumers. So you're going to sell pretty close to what you did before. You'll lose a few, but not that many. So you'll end up with a higher price for each unit and only a couple fewer units sold. You'll end up making more revenue. Now, if the price elasticity of demand for your product is relatively inelastic and you instead choose to decrease prices, you lower the price in an attempt to gain more consumers. Because consumers aren't sensitive to a change in the price, you're not going to get that many additional consumers or sell that many additional units. But you will get a lower price for each unit that you're selling. So you'll end up decreasing your total revenue. So it's important as someone for a firm deciding how to price your products to know whether the demand for your good is elastic or inelastic, whether consumers are sensitive to a change in price or not. If consumers are sensitive to a change in price, you don't want to increase your prices. An increase in prices is going to end up decreasing the quantity that you sell. It's going to lower your revenue. If they are sensitive to a change in price and you instead lower prices, you're going to end up increasing your revenue. Again, because consumers are so sensitive to price. Now it's time to introduce a term that we're going to use throughout much of the rest of this course, and that's marginal revenue. So marginal revenue can be defined as the change in the total revenue as the quantity changes by 1 unit. So what is the additional revenue you're going to receive for 1 additional unit being produced? Now marginal analysis is just focusing on the next unit. So you can apply this not just the idea of marginal to not just revenue, but to a whole host of other ideas. And we're going to do that throughout the rest of this semester. Now the idea of marginal analysis didn't really click for me when I was an undergrad until I was on a school trip. There were a few of us, we went to a restaurant with one of our professors, and one of the students who was 21 was able to drink. I wasn't 21, so unfortunately I wasn't able to. But when he was having a beer, he was joking with our professor about the marginal liver damage from that one drink. And that's the first time it hit me that this concept can be used anywhere. So what was the additional liver damage he was getting from that one drink of alcohol he was consuming? Here we're going to be focusing mostly on business ideas. And we'll use marginal analysis to analyze the choices that businesses, people within, managers within the businesses are making. So the marginal revenue, the change in the total revenue resulting from changing the quantity by 1 unit. That 1 additional unit, what is that going to do to the total revenue? So remember earlier we said that throughout the demand curve, we're going to have different levels of elasticity. So at a certain point at the top of the demand curve, so in the example, in the figure on the right, between a price of $18 and the price of $10, the price elasticity of demand is going to be relatively elastic. So at that price, a percentage change in price is going to lead to a greater percentage change in the quantity demanded. Again, moving from $16 to $14, we go from 2 units to 4 units. So that decrease, the $2, which is a relatively small percentage of the overall price, is going to double the number of units that consumers are willing to purchase. So a large increase in the percentage of the quantity demanded. As we go on, as we move down the demand curve, when we reach $9, in this example, consumers are going to demand 9 units. So at that point, the price elasticity of demand is going to equal to -1, or the absolute value of -1, so 1. So a $1 change at that point, or say a 10% change at that point, is going to cause a 10% change in the quantity demanded. And then below that, so from $9 down to $0, the price elasticity of demand is relatively inelastic. So then we're looking at, so let's say a 10% change in the price is going to lead to a smaller percent change in the quantity demanded. Say we're going at this point from $4 to $2. At $4, consumers are going to demand 14 units. At $2, it'll be 16 units. So we're cutting the price in half, so dropping the price by 50%, and we're only seeing a much smaller percent change in the quantity demanded. So again, it's relatively inelastic. Now the figure on the bottom shows the relationship between the total revenue and the quantity of the product being sold. So now we can see that that's a curved shape, so it increases when the demand is elastic. The total revenue is going to increase. It's going to peak where the elasticity equals 1 or -1, where it's unit elastic, and then the total revenue is going to fall when when the price elasticity of demand is inelastic. So that line shows the total revenue, but we can think of the marginal revenue. So for each additional unit being sold, what's the change in the marginal revenue? So at first, the marginal revenue is high and positive. And as we increase the number of units, it slowly decreases. So initially, the marginal revenue, see it's like $10, $8, $6, going all the way up until a certain point. At that peak, when the total revenue equals 80, so the number of, or the quantity of whatever product being sold is 9 in this case, that's where the total revenue peaks. At that point, the marginal revenue is going to be equal to 0. So at that point, selling one additional unit is not going to increase your total revenue at all. Past that, we see the total revenue curve actually go down. At that point, the marginal revenue is going to be negative. So as you move down that curve from 10 units to 12 units to 14 units, you're going to see the marginal revenue actually decrease. So if you're a firm and you're producing these additional units and selling them, you're actually going to be losing revenue. Now we can use this to actually draw the marginal revenue curve. Now if you go to table 4.4 in your textbook, this shows a demand schedule which includes both elasticity and marginal revenue. And that's where the numbers for this are coming from. And basically, at the point with the vertical line here and the figure on the right, that's where the elasticity of demand equals -1. Remember, when elasticity of demand is unit elastic, so it equals 1, marginal revenue is going to equal 0. So we can plot the marginal revenue line starting from where the demand curve crosses the y-axis, so where the quantity demanded is 0, and take that all the way down so it crosses the y-axis, or the quantity being bought and sold, or in this case quantity demanded, where that crosses vertical line straight down from where the price elasticity of demand is unit elastic. Past that, remember, where the price elasticity of demand is negative, at that point the marginal revenue is negative, so it goes there below the 0 on the y-axis, or the total revenue. And if we included it further, it would go down and down even farther. You see, if you look at the table 4.4, the demand schedule, the marginal revenue for when the price is $4, so there's 28 units being sold, marginal revenue is -10, so it's going to be far below the x-axis. But again, this just highlights that where the price elasticity of demand is elastic, so the upper end of the demand curve, the marginal revenue is going to be positive. And it's going to decrease all the way until we reach the unit elastic point. Again, that's going when we had the total revenue curve on the previous slide. We saw that was the peak of the total revenue curve. And then once we go past that point where the price elasticity of demand equals 1, where the curve becomes inelastic, so consumers aren't that responsive to a change in price, once we go below that, the marginal revenue is going to be negative. Again, it's going to be negative because even though you're selling additional units, you're not going to sell enough additional units to account for the lower price. Because at that point, consumers' demand is inelastic, so it's not responsive to a change in price, you're not able to attract enough new consumers or to sell enough additional units to the same consumers to be able to make up for the lower revenue per unit. On the other hand, where the price elasticity of demand is elastic early on in the curve, as you're dropping there, you're able to attract a lot more new consumers or have your current consumers purchase more. So the quantity that's being demanded by consumers is increasing a lot more than the price is increasing. So let's end this discussion on the price elasticity of demand by looking at a few examples of how economists have estimated what the price elasticity of demand is for certain products. So for coffee in the short run, the price elasticity of demand is -0.2. So it's relatively inelastic. Consumers don't have a very strong response to a change in price. In the long run, the price elasticity of demand for coffee is -0.33. So again, we see that in the long run, goods tend to be relatively more elastic. Consumers are more responsive to a change in price. In the short run, there may not be a lot of other alternatives for caffeine. Maybe you can switch to tea. Maybe your coffee shop sells some tea, Maybe you can buy a Red Bull from the vending machine, but there are some differences. So in the short run, people may be less willing to do that. Over the longer run, though, they do have more options. And some of it can be just getting more sleep. Some of it can be lifestyle changes. Some of it can be, it takes a while to get accustomed to the taste of tea, possibly. I don't know. I don't really drink tea because I don't like it. But maybe if I had it enough, then I would start to like the taste, and then I would consider it a substitute for coffee. We have kitchen and household appliances, which is negative 0.63. So again, that's still relatively inelastic. Consumers aren't very responsive to a change in price there. Meals at restaurants, on the other hand, are negative 2.27. Excuse me. So consumers, the price elasticity of demand for meals at restaurants is relatively elastic. Consumers are sensitive to a change in price because this is considered more of a luxury. People are willing and able to purchase goods at food to be cooked at home, and there's a lot of substitutes. So there's a lot of other restaurants you can go to. So if the price of one restaurant you like increases, well, you can just go to another one down the street and not spend as much money. So because there's a lot of substitutes and is considered a luxury, there tends to be higher price elasticity of demand. And finally, U.S. oil demand in the short run is negative 0.06. In the long run, it's negative 0.45. So we see it's much more elastic in the long run than in the short run. And again, this should make sense. If gas prices happen to increase one day, you really don't have a lot of choices that morning. You still have to get to work or get to class or whatever. There's not a lot that you can do that day about it. And it's also more of a necessity than a luxury, again, because people tend to have obligations that they have to do. But in the longer run, there are a lot more substitutes. And we gave the examples several times in slides throughout this chapter.